Good morning. This presentation will introduce the installation of the MEDINA framework. We have divided the session in 5 chapters. First, an overview of the hardware infrastructure and the installation of the Kubernetes cluster. Following is an overview of the main tools used to build the MEDINA framework. Next, we will go into more detail about the CI/CD pipeline, including a demo. And finally, some pointers for further reading about MEDINA. To put in context, the MEDINA project aims to provide a framework of tools and techniques supporting the continuous audit-based certification of cloud services in the EUC standard. MEDINA framework has been developed following an agile and DevOps approach, and its functionalities are made up of the collaboration of different microservices. Let's see an overview of the hardware infrastructure and the Kubernetes cluster installation. MEDINA hardware environment consists of 4 virtual machines. A dedicated VM hosts the CI/CD automation engine, the tools that support the CI/CD processes, and the Kubernetes cluster management. Then, there are 3 VMs for the 3 nodes of the Kubernetes cluster. The MEDINA framework is installed on Kubernetes. We created 2 different environments, one for development and one for test. Both environments are implemented on a 3-node Kubernetes cluster that virtualizes these environments, making them independent and isolated. These environments run all the MEDINA microservices. Different resources are needed to proceed with the installation and configuration of the cluster. We used Rancher Kubernetes engine to install, configure, and manage Kubernetes in the 3 nodes. Rancher is an open-source distribution that simplifies the installation and operations of Kubernetes. We used Rancher, but there are also other open-source engines, for example OKD. The Rancher client is installed on a console host, here represented by the yellow box, and it communicates with the nodes of the cluster through the Secure Shell protocol. Through Rancher, we have configured each cluster node to be both master and worker, guaranteeing fault tolerance and high availability. Kubernetes Dashboard is a web-based user interface for the Kubernetes cluster. It is helpful to deploy containerized applications to a Kubernetes cluster, troubleshoot them, and manage the cluster resources. To have access to the dashboard, it is needed to generate a service account token by creating a service account. We have 2 service accounts with different permissions. One is Dashboard Admin, which has access to all cluster resources, and the other is Partner User for the partner's access that has restricted permissions only to dev and test namespaces. We must use the token to sign into the dashboard. Now, a brief description of the required technologies for installing and running the MEDINA framework. In particular, the main tools used are a private Docker registry, Ceph, Git, and Jenkins. The microservices running on the Kubernetes cluster are packaged in Docker images and stored on a private Docker registry running on Artifactory. We used Artifactory, but there are also other open-source registries like Harbor and Nexus. To ensure that Kubernetes accesses the Docker registry, a specific integration has been carried out. A secret has been created with the registry credentials. This allows Kubernetes to pull the microservice image and then run it on the cluster. The images are pushed to the Docker registry according to the following structure that was agreed upon in the project. First, the MEDINA registry URL, followed by the work package, then the task, and finally, the image name with its tag. Here you can see an example of the URL associated with the image CNL editor, a component of work package 2, in task 2.4, with the tag equal to latest. On the right is shown the repository structure. Ceph is an open-source distributed storage solution for delivering block storage, object storage, and shared file systems in a single unified system. All the microservices can store their data in an easy and secure way thanks to the configuration of a distributed file system. Indeed, each cluster node provides 200 GB of storage, managed by Ceph and exposed as a single cluster file system. It ensures cluster state monitoring and handles data replication, recovery, and rebalancing. Ceph is deployed to the Kubernetes cluster by Rook, which is an open-source cloud-native storage orchestrator, which enables Ceph to easily run on the Kubernetes cluster. The Rook operator is a Kubernetes resource that automates the Ceph management and installation and turns Ceph into a self-scaling, self-managing, and self-healing storage service. Thanks to this configuration, data is replicated across the 3 nodes, 200 GB of storage is provided, and fault tolerance and high availability are assured. GitLab is an open-source version control service that helps developers store and manage their code, as well as track and control changes to their code. In MEDINA we have a private GitLab, provided by Technalia, where all the partners have uploaded their codes. The GitLab repository is divided into groups, that are folders, which contain the projects. The structure reflects the work package and tasks division of the MEDINA project. Also, Jenkins and Artifactory are organized following the same convention. The master branch has been used to store the stable project version. A CI/CD solution was put in place to support the MEDINA framework development and integration activities. We created 3 pipelines: build, deploy, and security. The continuous integration practice includes the management of the software source code through a versioning control system, and for this purpose, all the MEDINA projects are available on GitLab. Let's go into detail about the CI/CD pipelines. To automate the deployment process, we make use of the Jenkins seed job that will automatically create the pipelines for each component of the MEDINA framework. This is a plugin that consists of filling a form by entering parameters, such as the software repository URL, where to retrieve the source code, the container file descriptor, in Docker format, the generated container image for publishing to the private registry, and a list of 1 or more Kubernetes deployment manifest files. This procedure is quite the same for all components, because all the CI/CD tools involved are organized to simplify the deployment with a convention, agreed upon by the consortium. The build pipeline is triggered automatically at every push of a project in the MEDINA public GitLab, and automatizes the build of the project, the creation of the Docker image, and its push on the Technalia Artifactory, the private Docker registry. By default, the image is pushed with the latest tag, but there is an optional phase to tag it differently. Then, if no errors occur, the deploy job is automatically called. This will automatically deploy the component to the development environment by default. From the appropriate drop-down menus, the user can select which Kubernetes environment to deploy and choose the image tag. Finally, the security pipeline starts automatically. To guarantee quality and assurance in the overall workflow, the security pipeline has 3 types of security analysis. Static code analysis, for checking the source code. Container security, for scanning vulnerabilities in the container packages. Software composition analysis, for spotting security issues in third-party libraries. A brief summary of what we have seen so far. The MEDINA integration environment is composed of 3 main components. The code versioning, which is hosted by the GitLab provided by Technalia, and here we have our code, our Docker file, and all the Kubernetes files needed to deploy and run our component. The private Artifactory Docker registry, also provided by Technalia. And the Kubernetes environment, where all the MEDINA microservices run. So, the user has to push his code on GitLab, then build the Docker image and push it on the private Docker registry, then deploy it on Kubernetes, by applying all the different Kubernetes manifest files that are needed for deploying his software artifact on Kubernetes. We have automated all these steps through the use of the Jenkins automation server. Now, let's see a demo of the CI/CD Jenkins pipeline.
This is our GitLab, structured in work packages and tasks. Let's go, for example, on work package 5, task 5.2, in the Spring Swagger template, which is the job that we are going to deploy right now. On our Git, we have a Docker file on the root and a Kubernetes directory with all the needed Kubernetes files. Let's go on the Jenkins dashboard and log in. Also here we have the same MEDINA structure with the different work packages. In the work package 5, task 5.3, we created the MEDINA seed job. By running this, we will create 3 different pipelines. Let's go on the seed job and click Build with Parameter. Here I can select a specific folder. So in our case, we want to create pipelines for our Spring Swagger template in our work package 5 task 5.2. As we can see here from the Git. In the job base name, I specify a job base name, typically the component name, so Spring Swagger template. GitLab URL, to get this, go to GitLab, on the job, go to clone, and clone with SSH. Just copy this URL, go back to Jenkins, and just paste it. Here we can specify the GitLab branch to be used. Now we leave the default master value, but you can have your own. From build template, this will specify the commands that are needed to compile and package your code. We have prepared a couple of models already available. One is for Maven-based project, so for project created in Java. Then there is npm for Node.js, and finally a generic one that we call empty here, which can be customized by the user. In our case, this is a build made on Maven, so it is a program written in Java, so just select Maven. The Docker file relative to the root directory, and then the image that we will push to the private Docker registry on Artifactory. In this case, the image follow our convention, which is exactly work package 5, the name of the task, and then the component name. The latest tag will be added automatically. And finally, we have to specify the YAML files that will allow us to deploy on Kubernetes. So in this case, they are exactly this. So just copy and paste. For our scope, we just need the deployment, the ingress, and the service, SVC. So if we go back to the Git project in the Kubernetes directory, here we can see that we have several files and we have deployment, ingress, and services. Okay, go back to Jenkins and now just click on build. Build will take a few seconds. So we can see here also the build finished successfully. If I click on these green check marks, I can see the log file. It generated 3 jobs: Spring Swagger template, build, deploy, and security. So if we go back to work package 5, task 5.2, we can see that these 3 new jobs have been created. This icon means that the job was never run. So this is the first time we run this job. So if we open the build and go on the left to configure, here is the pipeline that is created automatically. And here, let me open a little bit. Here is the begin custom build process, the one that specifies the container that we will use to execute the build, so the Docker image, and also the argument, the command that will be executed. In the compiler, we'll perform a Maven clean compile and pass this setting, which is a property that provides some additional configuration. And here we perform the test. This is something that will show you in Jenkins the result of the test. And finally, package the application. The deploy and the security pipelines can be used as they are, so typically the user doesn't need to customize them. The only one that you need to customize is the build job. So let's run the build pipeline, clicking on Build Now. The build starts and we can see the different stages. If we move over the mouse, we can see some logs here and also on the compile. Now it is compiled the code and you see running Maven and so on. There are also more detailed logs by clicking on this button. You will see here the console output, which is the full log. Right now it's called the deploy pipeline. If we take a step back, we can see that the deploy pipeline also runs automatically. This means that the build was successful. If we click on deploy, we will see that each stage have also been completed. It is very fast, so it has already been deployed. And finally, we can see that the security pipeline is also running. So now we can access the Kubernetes dashboard to see that our pod created automatically by the deploy pipeline was created 34 seconds ago. Okay, let's go back to the Jenkins dashboard. We can see that the security process is also finished. If we click on the build again, the build now has become build with parameters. Then it automatically changed his name because it added the possibility to specify an additional tag. For example, I can specify 100, and if I click build, it will create the code as before. It will always create the latest version and upload it to Artifactory, but in addition, it will also create version 100 and push it. If we look at the deploy, here we have the build with parameter as well. Here is a specific form where we can specify the target environment. In Medina, we have two environments on our Kubernetes cluster, the development and the test. Here we can select a tag, usually the latest tag, but for example, I can specify that I want to install 101 tag on the test environment. From YAML field, if necessary, we can overwrite all the Kubernetes files. For example, an idea may be to have different deployment files for each environment. So you might have one called dev and one called -test if they are different. If, however, the Kubernetes files are the same for both environments and therefore the ones used in the seed job, we can leave the field empty and click directly on build. Here we can see some comments that show us where the build was deployed, in this case in dev, with the latest tag of the image. Finally, we can go to the security. Here we have static code analysis, where we analyze the source code. Here we use a tool called SendGraph. It is an open source for static code analysis of multiple languages. Here we scan the container security. If containers contain packages with known vulnerabilities, we use the tool that is called Anchor Gripe, and we check if your code has third-party libraries. So if we are using a jar file or if you are using JS library that contains known vulnerabilities, it will be detected at this stage. Finally, we integrated a tool called Defectoso Security Report, which I access if I click here on the left on Defectoso Security Report, which shows the result of the analysis. For example, this is a critical error that finds the log4j vulnerabilities, but we have also other criticals. If we go down, here we have high severity, for example, using an old version of Spring. But we also have other types of vulnerabilities, for example, on Kubernetes also. This error, it is saying that this is running with a writable root file system. This is a low vulnerability that could be improved. So it checks not only your code, but it also inspects your YAML file. Okay, that's all for the presentation for the live demo. Thank you for your attention.
To conclude the presentation, here you can find some links to useful resources about the MEDINA project. If you need more details about the MEDINA project in general, you can visit the official webpage on the first link, where you will also find all public deliverables of the project. Project-related videos, such as demos or training videos, are also available on the MEDINA YouTube channel. The third link points to the MEDINA community in Zenodo, where, among other things, the papers produced during the project are available. Finally, the source code of the project is available at the last link in the MEDINA Git lab. And that's all. Thank you and goodbye.